about it. Okay. I'm so sorry. The buses were in fact very late. Oh, I forgot. I gotta close that. Ah, okay. Forgot about that. The way that I do that is I undo the crop, and then I just kind of go to interact, and then pop this over here. Boom, kill it. So, alright. The last time... Oh! Did this get resized? Do I have to do that every time? Oh. Didn't mean to do that. Sorry. So, all I have to do is, like... That size is probably good, right? Let me move that here. Yeah, that's fine. I hate how that's going to be, like, an inconsistent size now. I should probably see if that's a setting that I can do. Like a window size setting. Nope. This is just going to have to be different every time. Well, that seems like an oversight. Okay, so. Here's the deal. When I was in class, I realized for the problem that I was... Oh, shit, yeah. I should probably change that to... crop, color key. Yeah, alright. And I'll keep that here for now, because I'm going to have to change that again. But I kind of realized that for, and I'll get the lo-fi going. It's just it's been a hectic day for me. I gotta head to bed early. Okay. There we go. Testing. Alright. So. Oh, and I should close my Spotify so that nothing accidentally plays. Big brain. Alright. So here's the deal. I'm gonna get my remarkable stuff set up. And I'm gonna go through the problem that I fumbled last time, because the solution was actually very elegant. My integration by parts was good. It's just that I had neglected to consider, one particular thing. So, yeah, we're gonna get this set up. Okay, we're gonna go crop. We're gonna go here. We're going to change it to light mode. Then we're just gonna use the other color key. And then we're gonna crop it again. Wonderful. It kind of looks like ass up against this background. But, once we switch into a lighter one, which will happen in, ideally, a matter of seconds. A matter of seconds, sorry. Again, I'm pretty hectic today. I'm all over the place. There's much to do. And some stuff to announce. Okay. I didn't change the stream info from last time, because we're pretty much going to be doing that. We might not study for very long tonight, because we got lab early tomorrow, you know? But it is what it is. So. My files. Okay. So we're going to begin, once again, with, calculus of variations. And we're going to open... Where was our new problem set? Here? Fuck. Ah, here. Excellent. So... Oh, shit. I'm not... Oops. Sorry. Again, pretty scatterbrained. Got 2 hours of sleep. And I have been up since, like, 11. Anyway. Hello? Okay, there we go. Wonderful. Are we so back? Are we back? Oh my god, we're so back. Alright. And my chat works! Woo! Let's go, chat. Now, I want you to pay attention to what we've got cooking. So, in essence, right, where we fucked up last time is we'd written just this, right? But in reality, u was equal to t, right? When we did integration by parts. See? Right here, we had u set equal to t. So it's because I made that silly mistake, right, that we actually get to say that it would be x dot t minus 1. And then I think it would be minus, right, if I'm not mistaken? Yeah, minus, right, no, plus x dot of 1 equals 3x, right? And now we can use our initial conditions to solve for things, right? So because we know our initial time, right, we can find any other time. I don't know why they gave us both 1 and 2. We really only need 1. You know what I'm saying? But we use our initial conditions, right? And we can basically use that to show when t is 1, this just goes to 0, which means that x dot of 1 is equal to 9, right? Consequentially, x dot of 2 is equal to 54 minus 9 is equal to, let's see, minus 10 plus 1, 45. Whoa! So we found our values. The problem is that we haven't sufficiently shown that this minimizes it, but we did find, you know, any arbitrary value of the derivative, I suppose. Right? So, you know. Because what we could do from here is we could subtract one from the other, and then integrate once more. If we wanted to. As a matter of fact, let's. We can get an expression for x. Yeah. We can get an expression for x in terms of t. Oh, no, we can't. I just realized this is the... I don't know what the second initial condition is for then. But this gives us our answers for both of those points, right? So we can solve the integral effectively, right? I think. Because... Okay, no, there's a little more work to do. This is progress, but it's not been sufficiently shown yet. Oh, wait, is my timer bugging? Is it clipping? Are we like so not back? Wait, and then if I move this out of range. Oh, wow. So that breaks the display, huh? Oh shit. Oops. There we go. I'll keep that somewhere on screen then, because I don't want it to be all messed up for you guys. There we go. Okay. Wonderful, wonderful, wonderful. So let's go back to the problem statement. Show the extremal provides the global minimum of j. Extremal of the function. So, let's look up an extremal, shall we? Extremal. Functional. Okay, yeah. We just solve Euler-Lagrange. To sufficiently prove it, though... No, I guess that's it. I guess that's problem over. Because now we... Wait, hold on. Let's see if it's really problem over. Give me a second, guys. That's okay. No, but I need a good expression. And I didn't get, like, an expression out of that. So, it's worth another try. It's worth retrying. Actually, I think I'm gonna copy the homework here. It's not really homework, but you know what I mean. Practice work. We're gonna duplicate it without edits, so just the original document here. I'm gonna start copy. Okay. So this time around, we're gonna be a lot more careful. Right? And we're going to take the Euler-Lagrange of the inside. So we're going to do our best to solve what we got here, using what we know. So, starting at a new page. I don't know why I'm, like, tweaking so much, because, like, oh, come on. Really? Hello? There we go. Wonderful. Yeah, I don't know why I'm, like, tweaking the fuck out. Because in my mind, right, this should be easy. You have, x dot over t to the third. Is it x dot squared, I believe? Yeah, x dot squared over t to the third from 1 to 2 dt. Right? Yeah. So then if we solve the Euler-Lagrange, right, this has no x dependence, right? And because this has no x dependence, we can just say d dx of j is 0, right? But it does have t dependence, right? So we have to say that d dx dot j equals 2x dot over t to the 3 equals... My friend suggested I use power rule instead, so I'm gonna do that. Just because, and I quote, fuck the quotient rule, all my homies hate the quotient rule. I don't disagree, so, you know, whatever. And then we're going to do... d dt of that, which gives us 2x double dot t to the minus 3 minus, just because it's going to be times minus 3, 6, oh, shit, yeah, 6 x dot t minus 4 equals 0. We'll factor out everything, which gives x double dot minus 3x dot t minus 1 equals 0. Which gives us the same result as before. X double dot equals 3x dot divided by t. So, Lagrange... Or, sorry, Laplace... What am I doing? Laplace transform is probably the best thing you can do here. However, I'm not going to do that. Because I want to solve it the way that it was probably intended to be solved by the people working through this particular book. Also, what is my... I gotta check my time. Do I keep it visible on my screen over here? So that way I can... Perfect. Okay. So, I'm going to look at an ODE solver just to make sure I'm not losing my fucking mind. Okay? Sure. Yeah, whatever. Or I guess it's not an ODE, is it? Is that a PDE? Whatever. So here's what I'm gonna do. Put this around here. Hopefully that, yeah. So then I can just go here. Yeah, so this is an ordinary differential equation of the first order. Can I really be done using separation of variables? I'm dumb. I'm straight up stupid. I would like to formally apologize. That's crazy. Alright. I notation diffed myself. Here's what's up. Oh shit. And then here's how we solve. Dx equals 3 over t dt no, wait. Should be dx dt? Question mark? Okay. No, hold up. I can't lie, okay. Yeah. So, d squared x dt squared equals 3 over t dx dt and then I think we can take a dt from the bottom and remove that, so this is kind of a scuffed way to do it, because this isn't, like, practical, but it works. Three over t dx. And then I feel like we get dx dt equals 3 over t dx equals 3 over t dt, which implies that x is equal to ln of... But that doesn't make sense to me. I can't lie. That doesn't make sense. There is a better way to do it. Okay. I looked at a solution thingy. There's a much nicer way to do it than I was just doing it. Which is... we can instead say this is actually dx dot dt equals 3x dot over t. And then we can separate the variables here. So we get 1/3 1 over x dot. I want to separate those just for the sake of it. Dx equals 1 over t dt. So this is ln of x dot. Okay, this is much better. This is 1/3 ln x dot plus c. Equals ln of t plus c2. So using the first initial condition, wait, is it really? Oh, yeah, because it's dx dot. Ln x dot because we're trying to find the initial conditions for the... Wait. No, I'm dumb. We only need one of these. We'll keep it here. Plus C1 equals ln of t directly implies x dot equals... And we're going to be a little evil about this. NN? No. The ln of t plus in this case it's minus c1. It doesn't really... The sign on it doesn't really matter. It's an arbitrary constant, but minus C1 times 3. And it's e raised to that power. So x dot equals e to the three ln t e to the minus 3c1. So x dot equals t to the 3 e to the minus 3c1. Doesn't really matter if it's minus or plus though. So what next? Well, we can then integrate again, I think, because this is dx dt equals t to the third e to the minus 3c1. I guess that's a constant, so we just have x equals 1/4 t to the 4 e to the minus 3c1. Actually, let's just call this c1. This just turns into c1. Not like it matters. Plus c2. And we can figure this out. So when t equals 1, if t equals 1, that's just 1/4 e to the c1 plus c2 equals x of 1 is 3? Yeah, 3. X of 1 is 3. Oh! Shit! Hi! Sorry, I was locked the fuck in. How's it going? Oh my god, you're here! Woo! I figured out my problem. And my problem was that I was being silly. So instead of directly integrating dx dot dt, I ended up trying to integrate d squared x dt squared, which is, it's the same thing, it's just less convenient for our example. We could actually just do a straight up separation of variables, and it works out very nicely. And I neglected that. It was a basic ODE, and I fucked it. Not anymore though, because we're solving it now. This stream, by the way, will be a little bit on the short end, and I want to formally apologize for that. I was late because the bus ran late. Not great. Yeah. Oh, I'm also gonna try a new doc, because there's a thing called stats. Whoa! Yeah, it just shows my... What is this? Yeah. Okay, there we go. Yeah. But you're here for the big solve. So, basically, right? We know that x is given to be 3 in this example. So then we multiply both sides by 4, which gives e to the c1. Wait, what am I doing? Hold on. I can simplify. I can make my life so much easier. Okay, check this out. We're actually just going to say that this is an equivalent statement to x equals 1/4 t to the 4 c1 plus c2. And that's just true. That's just truth. And now we can work from that. So now we can say that 3 is equal to 1/4 of c1 plus c2. And then that implies that 12 equals c1 plus 4c2. Which means c1 equals 3 plus c2. Okay. So now we've solved for our first constant in terms of our second constant, right? And now we can actually determine from here the value of our second constant from our first initial condition. So then we have x. We're gonna start with 2 now. So we have 18 equals 2 to the 4 is 2, 4, 8, 16 should be. 16 over 4 is just 4. So it should be 4 C1. So it should be 16 3 plus C2 plus C2. And now we get 18 over 16 equals 3 plus C2 plus C2 over 16. Not the best way to do it, I will admit. This is a bit of an oopsie. It's a bit messy. So then what we do is we can subtract this by 3. So 18 over 16 minus 3 equals C2 of 17 over 16. Sorry for the messy workflow. It's just, you know, when I get in a groove. So then, multiply out the 16, we get 18 minus 3 times 16. 3, 16, 30, 6, 12, 18, 30 plus 18, 48. Minus 48. Equals, so it's 8, 8. That cancels, so that's 40 minus 10, so minus 30. Minus 30 over 17 is C2. And C1 is equal to negative 120 over 17 plus, is it 12? Am I on the money here? 12. Yep. So these are our values for our constants. Right? Cool. So now we can try to take our first derivative with respect to t equals 1. No, it's just t to the 3. We already know it from up here. T to the 3 C1. And that would be T to the 3 for times our value. Oh, wait, I have a copy and paste feature. What am I doing? Check it out. Copy, paste. Hell yeah. First opportunity to do that in a while. Wonderful. Fuck yeah. And so yeah, we get our value that way. We have done it. We have solved the Euler-Lagrange equation for this problem, and it is complete. Yeah. That was actually a clever little trick that I forgot how to do. So that's done. Yeah. In about 10 minutes, I'll probably end up having to go and do some, like, lab notebook stuff and, like, grad school application stuff. So I'm gonna see if I can work through the problem statement of number 2 first. See if I can get an idea for how to solve it. And, oh, yeah, you weren't around at the very beginning of the stream, but basically I kind of announced that I have a project that I'm working on that I will tell you about in just a moment. Or actually, since I'm so limited on time, I could tell you now. Hold on. I have a little list of invention ideas here, right? And here, let me pause my thing so that it's accurate. There we go. Yeah, so I have a Minecraft stream coming up, right? And I'm going to recreate, ideally, I'm going to see if I can do that. I'm going to recreate the IBM 7094 in Redstone in Minecraft, if I can. So I was kind of workshopping it, right? I was like, okay, so voices have, like, a waveform, right? And then I was like, well, how do these, like, waveforms work? So I was like, okay, if I speak, right, there is an amplitude to my voice, which is how loud it is, right? But then there's also pitches, right? So the pitch is controlled by the wavelength of the sound wave. The how loud it is controlled by the amplitude, I think. I didn't look up the amplitude one. I did know the pitch one. So, because of that, I was like, well, how can we create, like, a vocal synthesizer using, like, note blocks or something, right? And for that, I suggested that if the only components of voice, and keep in mind, I haven't actually done acoustics yet, so I'm going to have to look into this a little bit, but if the only components of voice are your pitch and how loud you are, varying with time, right? This is something you could totally replicate in Minecraft, where time is your tick rate instead. So time is sort of discrete, as well as loudness being discrete. So this is your basic setup, right? So we would need to have some function of note blocks with certain pitches and a certain amount of those pitches, right? So the setup would look something like this, right? We have redstone running across a line of note blocks of a certain pitch, and ideally that would make it louder, right? I don't know if that's how it works yet, but if it is, if we have that variable loudness, we have a quantized loudness that I will convert from decibels to a value called note block. Nah. Relative to my nah, you should see my classmates, dog. My classmates are on some insane shit, right? Like, compared to them, I'm pretty mid-tier. I don't even know if this will work. This is just, you know, my chicken scratch. This is the idea, right? But basically, I was like, okay, so if we can have these note blocks kind of, like, stacked up in certain quantities, we can maybe synthesize a vocal track of some sort. I was also thinking about it because you had, like, sparse voice lines on occasion in very old games. Let me see if I can find an example, actually. Here, I'm gonna fix up my chat, and I'm gonna see if I can open a YouTube video real quick and find a good example. Here, hold on. I'm gonna stop sharing. Stop sharing. Alright. So I'll fix up my chat, and I'll see if I can find that for you. Yeah, because I'm also into game dev. And I have been for a while. But, oh, yeah. I'm gonna real quick actually walk you through how the thing I do works for the chat. Because I do it in a really lazy way. So, this is a color key. Or, at least, there we go. Right, so basically what I do is I crop the pop-out from my chat. Oh, what project are you working on? I go here, dark mode. It's a video game. Excellent. What genre? Like, what's the basic idea? Let me see if I can find. Also. Okay, horror action. Is it more like story focused, or is it more of like a party game? What's the situation there? Here, hold on. Story focused? Okay. Hold on. Sorry, I am, actually, I should pop out my chat. Or I should just use the chat pop out. Hold up. Which, there it is. Time to pop out my chat. Is it chat / pop out? I don't remember my own chat pop out link. I'm crying. Can I actually? No, I can keep this here. Oh, holy shit. No. Go back. Okay. There we go. Yeah, what was the first? Ah, but so it's Berserk. Okay. Berserk. So let's see the first ever voice lines in games and see how they sounded. Because ours should ideally sound similar because it's Minecraft. Here, let's see.
Intruder alert, intruder alert. Get the intruder. The intruder must not escape.
Yeah, so that's the style that I'm trying to replicate, but with like note blocks instead. So I'm actually, instead of looking at the IBM machine first, which is infinitely more sophisticated in terms of its vocal, well, no, it's I can't make that claim. I don't do computer engineering, so I can't make that claim. I would say it's more sophisticated, right? But it's also older, I think. So, I mean, actually, let me check. Let me check how old it is. When was the 1794 made? 1961. So, if that was 1961... Yeah, okay. Berserk came way later. So the idea here is that I want to create a vocal synthesizer that is at least as good as the first one in Minecraft. So I actually might have better luck looking at how the Atari synthesizes vocals. as opposed to the IBM. Someone else actually did also make a vocal synthesizer, but they used resource pack stuff to do it. I want to do it with just vanilla stuff, without resource packs. So we'll see. Yeah, so if you want to see, like, the, like, research process I'm going to be doing for that, and if you want to actually be a part of it, it's going to be, oh, thank you. It's going to be on Saturday. It's on the schedule. I'm also going to have to adjust my schedule for Monday and Wednesday streams, mostly because, in winter, the bus is super packed, so it actually gets around super late. So I wasn't able to get home in time for my scheduled stream, which is what I was kind of worried about. You'll be there. Wonderful, wonderful. The layout I was thinking is, instead of my like shot clock on the left, right? For the Minecraft project, I was thinking of keeping a PDF of the schematics for the IBM 7094 on the left, and then my Minecraft in the center window. And then I would just keep my Minecraft windowed, and we would go into like a redstone world, and it would be like completely empty, and I would run a couple of experiments with note blocks and stuff. I might actually do the note block stuff preemptively, so that I know by the time I stream how feasible it is. But yeah. Also, I appreciate you popping by the stream. That was really nice. I didn't think anyone was going to show up today because I was super late. That was nice. Yeah. Then, boop. Put that lo-fi back on. You do your best. Yeah. Also, I think, I'm not sure if the Discord link in my Twitch still works properly. If it doesn't, I'll update it. Aw, that's so sweet. Thank you. Yeah, but I'll have to fix it if it doesn't. The server's pretty dead. Because I stopped streaming for a long time until I realized, I can just stream the shit that I do by default, day to day. So yeah. You'll make it alive. I appreciate that. Yeah. If I had a link. Yeah. I'll make sure to fix the link. Or make it more obvious, maybe. Actually, I should probably start over with another server. Because my old one is just mostly me and my friends, like, fucking around. So, I will let everyone know when that's updated. Yeah. Alright, well, thank you for stopping by. I'm gonna get to submitting grad school applications. Wish me luck. And, peace.